So how do you add vectors graphically? We use tip-to-tail method. So what you do is, if you're adding vector A and B, you start off of vector A, put the tail of the second vector to its tip, and then connect them. Then your resultant vector, which is the sum of the vector, will go from the tail of the first vector and end at the other's head. So then this is your vector, resultant vector A plus B. Okay? So let me show you more examples here. So how do I add U and T? So when you guys do this on the paper, try to make the same angle and try length. Same length. It doesn't have to be perfect, but it has to be close enough. So what I'm going to do is this. I can easily copy this vector. This is U. And where do I put my T? Tip to tail. Tip to tail. Then where's my resultant vector? Your answer will be from where you started and where you ended. Make sure you put the direction, and the length will give you the magnitude. And remember, you need to have both magnitude and direction for a vector. So you have to put the arrow. A lot of you forget to put the arrow, then you don't get full points. And try to circle it and label it. This is vector U plus T. That's tip to tail method. Again, U plus S. V, here's my V vector. And S, where would I put my S at? Here or here? Tip to tail, here. So then your resultant vector will be from here to there. So that is your vector V plus S. Again, make sure you put the arrow. Okay? Yes? This? Yeah, that's a notation for a vector. You can either put an arrow on top of the letter, or what else can you do? You can make the letter bolded, but it's hard to do it on the paper, so always just go ahead and put the arrow notation, right? Now, what if we scale it? What if you multiply by a scalar, a number? Then, guess what 2v will be? 2 times v, meaning the length double, but the direction stays the same. So where's my v? Isn't it fun to do this? I like it. So that's my 2v. Do you see it? I added 2 v's. So now you have to draw it as 1. So what would you do? Draw it on top of it as a 1 vector, and that's my 2v vector. And usually we don't put the arrow on top of a scalar, just on top of the letter. Okay? What about minus s? What if you multiply by negative? What will happen? What happens to the magnitude? Stays the same, but direction changes to the opposite side. So if this is my s, now this is my what? Negative s. So this is my negative s. Fun, isn't it? Physics, yeah. Physics. Vectors, yeah. Speed, velocity, we will cover a lot of stuff from physics. What about 9? Now, it's a combination of addition, subtraction, and multiplication. So first you do r. Where's my r? Right here. Half of t. Guess what half of t will be? Half of t, but same direction. So again, tip to tail. Some of you put it over here and get this as a vector, but that's not a tip to tail method. You can do that for parallelogram method, which is, do you want me to show you parallelogram method too? I will. I don't know. I don't get to see the progress checks anymore. So they used to ask, where they say use either parallelogram method or tip to tail. I always use tip to tail. What parallelogram method is, You put tails together and heads together, but you need 4 of them. So here's my R, parallelogram method. And half of T. So now you put T over here and over here. You see how we can make a parallelogram? And here's your R. So then your parallelogram method gives you wherever their tails are, you start there, and you end where their heads are. You see how these two vectors are same direction and magnitude, so you can use either way, but I personally think tip to tail method is easier. But you can, you have a freedom of vectoring, so you can choose whatever you want to do. So R, 10, minus 2V. What's minus 2V? That's same thing as R plus negative 2V, isn't it? So you do minus 2V. Where's my V? So this is my 1V. This is my negative 1V. Here's my negative 2V. So here I go 1 and 2. So my resultant vector goes from here to there. So when you get confused where you're ending, think about it as a direction. If you went here to here and went up this much, just go ahead and represent how much you move from here to there, right? So label it R minus 2V. If you have a highlighter, you can highlight it, circle it, whatever you want to do to make it clear what your answers are. Okay? Now, can we add vectors algebraically? Of course. You don't have to draw them. We're going to just do simple expressions. So U plus V, what would you do? We call the sum of the vectors a resultant vector. And what you do is you just go ahead and add vector U, x component of vector U with x component of V, and y's together. That's it. So here's my U plus V. Where's my U vector? Negative 2, 5 plus V, negative 1, 4. Again, what do? You just combine the x's together. Still component form because it's a vector. Negative 3, 5 plus 4, which is 9. How easy is it? What about V plus W? V plus W, you do negative 1, 4 plus negative 9, negative 3. So you get negative 10 plus 1, 4 minus 3. So that's, you put comma, right? So let's say that this was just positive. Yeah. What about if you multiply by a scalar? This time now, you triple both x and y. So you have to distribute 3 to both x and y. So V is negative 1, 4. So now you get negative 3, 12. Distributed. Negative W will be distributing negative 1 to both x and y. So W is negative 9, negative 3. So they both change it to positive 9 and 3. Easy, right? So let's try 11. W minus V. So it is 3, 4 minus V, negative 2, 5. So it is 3 minus negative 2, which is plus 2, 5. 4 minus 5 is negative 1. Easy, right? 12, you're adding after you double your W. So let's just put V and 2W first. So V is negative 2, 5 plus 2W. Distribute 2 to the W's. So I get 6, 8. When you add them, you get 4 4, 13. Component form. So 13, last question. What are they asking you to do? What does this mean? Not an absolute value. That doesn't mean you just take out the negatives. In vector, these 2 bar means what? Find the magnitude. So what's 2w? So magnitude of 2w will be magnitude of vector 6, 8. Again, it's not asking you to just get rid of the negatives. You have to do the distance formula, right? That's a magnitude. Remember, the component form means it starts from 0, 0 and goes to 6, 8. So you do 6 squared plus 8 squared, which is square root of 36 plus 64, which is 100. So you get magnitude of 10. Here's an example of adding vectors. But we're going to go ahead and use only these letters to represent the resultant vector. So let's look at the first question. Vector C is this one right here. Vector C plus what? Vector D. This is D, but this is not tip to tail, so I have to move this over here. They're same thing, right? Parallelogram. If the diagonals bisect each other, so this is same as that. So then what will be the resultant vector? From here to there, so your answer for the first question is vector A. Second one, C minus D. C minus D this way, right? So then, what will be your resultant vector now? B. Okay. A plus B. A plus B will be what? A plus B will be 2C.